In this video, we're going to look at exactly what you need to know for the MCAT for kinetic energy, work, and power. Kinetic energy is the energy of a moving object. Here's the equation. It is 1/2 times the mass of the object times the velocity of the object squared. Here is your kinetic energy equation. It is saying 1/2 times mass times velocity squared is the kinetic energy of an object. This should make a lot of intuitive sense because a faster moving object has more kinetic energy, and two objects that are moving the same speed, the one with more mass has more energy. Now, what is work? Work is the transfer of energy to another object by applying a force to that object over a distance. The equation is F times D of force times distance. Now let's look at an example. Let's say we have a ball and we apply a force of 5 newtons to this ball. We continue to push the ball for a distance of 2 meters. We can use our work equation to do the force of 5 newtons times the distance that force is applied, which is 2 meters, to get a total of 10, and the unit is joules. We transferred 10 joules of energy to that ball. What that 10 joules allows us to do is figure out how much the kinetic energy of the ball changed. Let's say the ball started with a velocity of 0. Using the kinetic energy equation, we can easily see that the initial kinetic energy would be 0 if the velocity is 0. Let's give this ball a mass of 2 kilograms to then solve for the final kinetic energy. The final kinetic energy is equal to 1/2 times 2 times v squared. We know that it started off with 0 joules of kinetic energy, and then by applying that force, we gave it 10 joules. So we do 10 joules is equal to 1/2 times 2 times v squared. That means v squared is equal to 10 joules. And using some rounding, we can say that the velocity is roughly equal to about 3.2. This is a really common way that work is applied. You figure out the change in kinetic energy by doing your work equation, and then you use that to solve for the new velocity of that object. Now let's look at how we can use the change in velocity to figure out how much work is done on an object. I'm going to clear all this out to give us some space to work with. This time, let's say that the ball is 3 kilograms. It starts off with a velocity equal to 3 meters per second. There's a force that gets applied to it, but we don't know what that force is equal to. We know that the force is being applied for a distance of 5 meters. And then the final velocity is 15 meters per second. To find the missing force, we're going to have to use our work equation, and we will do work is equal to F times 5 meters. We're going to figure out the value for work by first finding the change in kinetic energy. The initial kinetic energy is equal to 1/2 times the mass of 3 kilograms times the velocity of 3 meters per second squared. That gives us 1/2 times 3 times 9 for a final value of 13.5 joules. The final kinetic energy is equal to 1/2 times the mass of 3 times 15 squared. 15 squared is 225, so we have 1/2 times 3 times 225. First I'll do 1/2 times 225, and I'll do some rounding to get a value of 113 times 3. 113 times 3 is equal to 339 joules. That means that our kinetic energy went from 13.5 joules to 339 joules. The change in that kinetic energy is roughly 325.5 joules. Remember that the reason the energy changed is because we applied a force to the object, and the change in that kinetic energy is equal to the work done to the object by that force. That means that we can take this 325.5 joules and plug it into that equation for work. 325.5 equal to the force times that 5 meters. With a little bit of rounding, we can see that the force is equal to 65 newtons. What we did with those two examples is showed how you can use work to find the change in an object's velocity, or you can use the change in an object's velocity to find the work. Now let's look at what is power. I'll just zoom out to give ourselves a little bit more space here. The equation for power is work divided by time. For most MCAT problems, the way that you will find the work done for this equation is going to be through similar processes to what we've already shown. And then all you'll have to do is figure out from the passage how much time did it take for this work to be done. Conceptually, the way you want to think about this, first start with the situation that we've already described where force is applied to an object. We talked about that force being applied to an object over a distance. Now we're just going to add in time. Let's take the situation that we just did where the work is equal to 325.5 joules because that force was applied to that object for 5 meters. For the sake of making the math a little bit easier, I'm going to use a value of 300 joules instead of 325, and let's apply this to two different situations. In situation 1, that work was done over a time span of 10 seconds. And in situation 2, that work was done over a time frame of 50 seconds. The power done in situation 1 is equal to 300 joules divided by 10. That gives us a final value of 30 watts. In the second situation, we have power is equal to 300 divided by 50 seconds because it took 50 seconds to apply all of that work. That is equal to 6 watts. What the value of the watts tells you is simply how fast is this energy change going to occur. Conceptually, you have to emphasize that the total change in energy is the same. It's simply how quickly does that change occur. Applying that to something like velocity, that means that the object starts at the same speed and ends at the same speed, no matter what the duration is, as long as the work value is the same. But it would just mean that the change in speed happens much more quickly. What I like to think about is how horsepower is used to talk about cars a lot, and frequently this goes into how quickly a car can accelerate, because the more horsepower a car has, the more work the engine can do on that car in a shorter amount of time. That means that the change in kinetic energy can occur over a shorter duration. Or if you want to think about something like the power given to a light bulb, we could give the same amount of energy to a light bulb, but if you spread that out over multiple days, the light bulb would be really dim. Versus if you took all of that work and all of that energy and condensed it into just a few seconds, that light bulb would be extremely bright. So in all of those situations, the work could be the same, but when power goes up, that means that that work is being condensed into a small time frame, so the change in energy is much more drastic, and you can feel this change by things like a faster acceleration or a brighter light bulb.